is the clean water that's going to groundwater discharge. It flows by gravity here out to those sand beds we looked at. And back to groundwater.
You call this the pipe gallery? Pipe gallery, yes. Sounds pretty deep. It's really deep in the ground, isn't it?
Yeah.
Why is it so deep in the ground?
Well, it just is what we need just to fit all the pipes and the pumps in here. It's just they wouldn't make it any deeper than they needed.
Yeah.
This is all the support system for the advanced treatment. All our pumps, the pump side, the air side is upstairs in those the blower room. These pumps pump our clean water up to the ultraviolet light disinfection for the final stage of our treatment before it goes back to groundwater. We're designed for 3.5 million gallons a day.
Now, how many people is that?
Well, we figure on the island, 110 gallons per person is kind of a standard formula.
Per day?
Yeah.
So how many people can we actually fit on the island in the summertime and still keep this thing going?
Well,
when are we maxed out?
We measure two ways. We measure the gallons and then we measure the strength. And we get a formula we call a pounds BOD load. And there's a couple ways to measure it. There's just plain gallons, which don't tell the whole story of the strength. We're good for 3.5 million gallons a day, but we're also good for 6,900 pounds BOD load a day. In the summer, for a few months around race week, we're around 4,500 pounds BOD load a day, which is a heck of a lot different than now. We're about 1,200 pounds BOD load.
And the maximum is what?
About 6,500, 6,900.
So at 45, we're at about 70% max.
Yeah, but it's just a few weeks. You know,
it's only a couple of weeks there.
In August.
No, but I mean, I'm just saying though, if we have 20% more people that come out here in the summertime, you're going to be 20% more, you're going to be almost at max.
Well, it'll take a while,
yeah.
and we can handle it, but well into the future. I mean,
you can adjust.
This plant, the technology changes so quickly that you plan for 20 years life.
Well, that's what I'm saying.
Yeah. What's going to limit the expansion of this plant is the hydraulics on the beds. We can't load our site with any more than 3.5 million gallons of clean water because that's it. What the groundwater will recharge. The game's over there.
If worst comes to worst, you can always dump it in the ocean.
Well, it's a state regulations.
Yeah,
it's hard to get.
In the old days, that's what they did.
Well, I doubt that would happen again.
Right.
What we'd have to do is find a groundwater discharge elsewhere, a different place on the island. Sconset has a groundwater discharge spot down in Low Beach. The Matticat plant they're talking about will have a groundwater discharge out that way. This site, we don't want to put more than the 3.5 million gallons of clean water. We can take 6,900 pounds of BOD load a day. This building was our old compost facility. This original 1991 plant made compost. Sure. And that was the old compost hangar. Well, with the upgrade, we turned it into a solids handling building. This is our main control room. Two more of these same computers that we have around the plant for just SCADA computers we run the bulk of the plant with. We also have the dewatering control HMI there. These touch screens that we use on other controllers are what they call a human-machine interface. Once we remove the contaminants from the waste stream coming through the plant, it ends up in sludge holding tanks. We concentrate that sludge holding tank sludge down to sludge cake, which goes to the landfill for composting.
All right.
And we're running we're dewatering today. This time of year.
What does the dewatering do? It takes out it takes the water out of that sludge.
Yes.
Oh, okay. And that happens here.
Yeah. With this control screen and with the equipment in this room here.
So what's the cake look like?
We'll take a look at it.
Let's look at the cake. What is that? What's that like? I mean, what can you use that cake for?
Well, it's a nitrogen source for the compost at the landfill. The composting operation out there.
So they throw that into that compost?
And it goes into digester. We'll take we got a truck.
So is that part of the process?
Yeah.
Do they need that stuff?
They need it. They need it. Yeah.
Tell me about it.
These are our 40 presses.
Yeah.
Microphone. They're out of Canada, Canadian presses, and they're expandable. Every one of them that we have here is expandable. And this tank right here, called the flocculator.
Yep.
What it's doing is it's binding all the solids together and trying to disperse the water to the outside. So you'll see that everything's kind of just bunched together instead of just being a soup. That's my polymer mixture. Right now I'm doing about 2.5 gallons or 60 gallons a day. And this is what we're looking for. Once we get separation in here, then we know we're going to get a good product coming out of here.
So that's it. Okay, come on, wait a minute. Stand next to him because he's got the mic on.
Yeah, I'm trying.
I'm looking at this.
This is our final product coming from across the street.
Now, what
We call it
is
cake.
that? Okay.
This is all our...
What is that? I mean, what
It's sludge cake.
it's sludge cake.
All
It's
sludge cake.
It's the dead bugs, it's the inorganic shells.
And it's also a lot of just
Is
biomass.
it dangerous?
Fiber.
Is it dangerous?
Not necessarily. It's compostable.
Yeah.
It's full of microbial life. Don't fool yourself. But the composting operation needs it.
Oh yeah. So it's solely used for the composter, though. How much of that do they need, though? My gosh, you can't use it all over there, can you?
Oh yeah.
Oh yeah,
They use every bit you give them.
Yeah, we get them.
Yeah.
But they mix it in with the big with the trash, and then it all goes up into the I lost the word now.
The tumbler, the big tumbler, the drum.
And then that heats it on its own.
Right.
And then it goes into the drying room.
And it's microbial.
And then it can be used as compost.
But it's a certain amount of days. You have to wait so many days. And you have to, Robert did a lot of composting in the past, but you have to rotate it and flip it and aerate it.
Oh yeah, I know that.
It's another step in digestion. It's more of the conversion of organic material to a soil amendment, a friable humus type thing.
That's our final product to take to the dump, and they put that in the digester out there.
And there it is.
And there's one aspect to this process that you're not going to get on film or with your sound is the odor control system. We have a 39,000 cubic foot per minute fan ventilating this whole operation.
Don't even notice it.
You can't smell anything.
It doesn't
No,
smell
you
bad.
can't smell anything.
It's a dirty smell. It's a soily
It's
smell.
organic.
Yep.
Yeah. So David, I mean, well, you know, I got to ask you, man. You didn't want to run for selectman?
No, I learned my lesson there. I did that 3 times. I'm happy right where I am.
Okay, good to hear. Good to hear.
So we're heading up to the lab.
The lab, man. Wow. This is like a hospital up here.
It's fancy.
It got all the drugs and everything.
Well, it's not drugs, but it's it's fancy stuff.
Fancy stuff.
This is Willie Lavelle. He's our full-time chemist. We really are fortunate to have Willie on the team. He was at the garage for years and years with a background in chemistry, having worked in environmental labs. We finally talked him into joining the wastewater side of things when we got the advanced treatment. He's a full-time chemist for us. Tell us what's going on, Willie, with the samples here.
What's going on here is we get the sample from the effluent and the primary effluent. And from the effluent we get here, you can see what is there.
Right.
We talked earlier on about the settlable characteristic of the effluent.
Okay.
And that's you can see that little bit of settleable solids in there.
So is this the final step?
No, this is what comes out of sewer
This is not
system.
the final step.
Comes out of the sewer.
That's what we start with.
It's coming from.
Why does this look darker?
That's the magic trick.
Oh, really?
Yeah.
Oh, all right, so there we go. Okay, I'm getting it.
Yeah, we get the settleable solids out easily in the clarifiers. And then we got this non-settleable high dissolved solids primary effluent. It goes into the mixed liquor I was talking about.
Yep.
These 3 beakers are various points in the advanced treatment mixed liquor process. But basically from the primary clarifiers into this stuff, we call it mixed liquor. You can see there's a flock in there, and it's a biological flock compared to the flock that you saw in the dewatering operation.
Why is it dark though?
Well, it's
the biological.
Oh, the biological stuff that you put into it to heat it down.
There's microbes.
Makes it dark.
Make it dark.
And then how does it go from that darkness to that's what it goes out as?
That's what goes
That's
out.
what goes out.
That's the treated.
After it's treated?
Yeah.
Yes.
Yeah, and this mixed liquor is treating the stuff here and producing that.
But the process that takes it from there to there, after everything you showed me, it must be very easy to get it to that. What do you go through to get it to that?
We use aeration.
Even
Oh, aeration.
Yeah.
aeration.
I see.
And go to the membrane filter
I see.
and to filter the sample.
Okay.
And you get the final.
Willie, you've tested all of this water, right?
Yes.
Would you drink that?
No.
Okay.
No.
Not recommended.
Not even if it was on ice?
No.
Okay.
Not recommended to drink.
Okay, but it's, how clean is it?
It's not clean to drink,
Okay.
but it's clean to discharge in the bed.
Okay.
Well, because of this state now we cannot discharge on the river, but it's safe now to.
Is it as clean as a river might be, or
Yes.
We compare it to Mycomet Pond. We get
do.
samples out of
and
Mycomet
it's
Pond.
very similar to that?
Similar.
Similar.
Slightly different. The pH, the strength gonna be a little bit different, but basically.
Now there was a little scare about Mycomet Pond recently about.
Well, it's had some problems. Mycomet Pond has problems.
Yeah.
And the profile, our wastewater profile, our effluent profile is a little different from the pond water profile.
Yeah.
There's a different assortment of contaminants in it. What the pond had a problem with fecal coliform, I think.
Yeah, fecal coliform.
And we don't have any fecal coliform.
Is that taken care of yet? Where are we on that? Do we know?
I don't know.
There's not much they can do, really, about that. They try to limit the nutrient load from the septics on the.
Is that where
the
it came
neighborhood.
from?
I believe they think a lot of it's actually from birds.
I see.
Yeah, in parts of the pond, the ocean side is worse than up towards the head of the pond. I don't know if they know for sure where the contaminants coming from.
Okay.
But we don't have our treatment process targets fecal coliform bacteria, and
Right.
there's nothing like that going on in the pond.
Right. Exactly.
So we don't have that problem, but there's all kind of ways to measure contaminants: the biochemical oxygen demand, the total solids, the total suspended solids, specific conductance. Profile similar.
Similar. And the BOD.
I think the BOD was about the same.
Yes.
It's not much different.
Okay, well, you know, I want to thank both of you for taking me on this tour and letting folks out on Nantucket see what really goes on, and looks like you're doing a great job.
Thank you.
Thank you. We enjoyed telling folks about it.
Thank you very much. We enjoy to come here, and we hope you're coming back again.